The majestic beauty of koi is best showcased in water that is crystal clear, yet achieving this requires more than just a simple pump. It demands a robust and effective filtration system. A good koi pond filter is the unsung hero of your aquatic environment, working tirelessly to remove toxins, excess waste, and organic debris that can compromise fish health and cloud your view. From submersible boxes to advanced multi-stage units and even natural bog filters, the right system is crucial for a balanced, thriving ecosystem. Selecting the perfect filter can feel daunting, but understanding the core principles of mechanical and biological filtration will unlock the secret to keeping your prized koi happy and your pond pristine. The essential role of filtration in a healthy koi pond. A robust filtration system is the absolute cornerstone of a flourishing koi pond, serving as both the pond's kidney and its liver to process and neutralize life-threatening waste. The majesty of koi is inextricably linked to the quality of their water, and without a reliable filter, the aquatic environment quickly becomes toxic. The primary role of filtration is to facilitate a crucial biological process known as the nitrogen cycle. Koi, like all fish, excrete waste which decomposes along with uneaten food and organic debris into highly toxic compounds, primarily ammonia. Ammonia is deadly to fish, even at low concentrations, and its removal is the filter's most vital task. This essential work is performed through a two-pronged approach: mechanical and biological filtration. Mechanical filtration acts as the pond's physical screen, trapping all visible solid particles, such as fish waste, dead plant matter, and food remnants before they have a chance to break down and pollute the water. This initial step is key for maintaining the crystal clarity that showcases your koi. Biological filtration, however, is the true life support system. This stage provides a vast surface area, often using specialized media, for colonies of beneficial bacteria to thrive. These bacteria are the engine of the nitrogen cycle, converting the harmful ammonia first into nitrite, which is still toxic, and then into the far less dangerous nitrate, which can be absorbed by aquatic plants or removed through partial water changes. A good filtration system, therefore, does not merely clean the water, it actively sustains a balanced, non-toxic ecosystem, ensuring your prized koi remain vibrant, healthy, and safe from stress and disease. Understanding the three pillars of koi pond filtration: mechanical, biological, and UV. A truly good koi pond filter integrates a trifecta of water management processes to maintain an optimal environment: mechanical, biological, and ultraviolet UV filtration. While the first two stages are fundamental for water health and clarity, the addition of a UV unit provides a critical third pillar of protection and maintenance. Mechanical filtration is the essential preparatory stage, removing larger solids before they decompose. This process relies on various media, from filter brushes and dense filter mats that physically trap debris, to modern high-efficiency equipment like sieve filters and rotating drum filters, RDFs, that use fine screens to pull out particles as small as 200 to 300 microns. Removing these solids first ensures the subsequent stages do not clog and can operate at peak efficiency. Following the solid waste removal, biological filtration becomes the powerhouse of the ecosystem, as detailed in the context. Its effectiveness is directly tied to the surface area of its media, where billions of nitrifying bacteria can settle. Media with high internal and external porosity, such as porous ceramics, Japanese matting, or dynamically moving media like Caldness K1, provide the necessary habitat to convert ammonia and nitrite into harmless nitrate, completing the nitrogen cycle. The third and final pillar is UV filtration, which addresses the smallest free-floating threats to clarity and fish health. While often called a UV clarifier, its primary function is to expose single-celled organisms, such as greenwater algae, bacteria, and viruses, to germicidal ultraviolet light. The UV light either kills these pathogens outright or, in the case of algae, destroys its reproductive ability, causing the cells to clump together, flocculate, so they can be easily captured by the mechanical filter. This triple-pronged strategy, physical cleaning, chemical neutralization, and sanitation, is the gold standard for maintaining the clear, stable, and pathogen-reduced water necessary for vibrant koi. Mechanical filtration, trapping solids and removing debris. Mechanical filtration is the crucial first line of defense in a koi pond's water management strategy, acting as the physical barrier that prevents large debris from corrupting the entire system. Its primary function is to physically remove solid organic waste, such as fish feces, uneaten food, sludge, and fallen leaves, before they have a chance to decompose and pollute the water. This preemptive removal of solids is essential for maintaining water clarity, but more importantly, it safeguards the highly sensitive biological filter. When solid waste is allowed to reach the biological media, it can clog the material, reducing the surface area available for beneficial bacteria to colonize and thrive. Furthermore, this organic debris will begin to decompose, contributing significantly to the ammonia and nitrite load that the biological filter is already working to neutralize. By intercepting these solids, the mechanical filter ensures the biofilter receives clean water containing only the dissolved nitrogenous compounds it is designed to process, allowing the nitrogen cycle to complete efficiently. The technology used for mechanical filtration ranges from simple, low-tech solutions like settlement chambers and filter brushes to modern, high-efficiency equipment. Advanced systems, such as sieve filters and rotating drum filters (RNEFs), have become gold standards for high-stock ponds. These automated filters use extremely fine screens, typically between 200 and 300 microns, to capture even the smallest suspended particles. Other common methods include skimmer filters, which remove surface debris like leaves and pollen, and pressurized filters, which force water through foam or pads. Regardless of the type, the goal of mechanical filtration remains the same: to remove solid materials completely from the pond system, thereby reducing the organic load, maximizing the efficiency of the biological media, and setting the stage for pristine water quality. Biological filtration, the engine for breaking down harmful waste. While mechanical filtration handles the visible solid waste, the true engine of a healthy koi pond is biological filtration, which completes the nitrogen cycle. This process is the necessary chemical conversion of invisible, highly toxic nitrogenous compounds, the dissolved waste produced by fish respiration, uneaten food, and decomposing organic matter, into far less harmful substances. The primary waste product from fish is ammonia, NH3, a compound that is lethally toxic even at very low concentrations. The biological filter provides a massive surface area for colonies of beneficial, nitrifying bacteria to thrive. The first essential group, Nitrosomonas, consumes the toxic ammonia and converts it into another toxic compound, nitrite, NO2. The second group, Nitrobacter, then takes over, converting the nitrite into the much less noxious nitrate, NO3, which can be tolerated by koi at higher concentrations and is primarily removed through partial water changes or uptake by aquatic plants. This two-step process, crucial for a stable ecosystem, is entirely dependent on the biological filter media providing a protected habitat for these microbes. The effectiveness of a biological filter is directly proportional to the available surface area of its media. Traditional static beds use high-porosity materials like Japanese matting, ceramic rings, and bioballs, but advanced systems have embraced the moving bed biofilm reactor (MBBR) design. MBBRs use specialized carriers, such as Caldness K1 media, that are constantly tumbled or fluidized within the filter chamber. This constant movement ensures a high rate of water-to-bacteria contact and promotes the shedding of older, less efficient biofilm, allowing the younger, highly active bacterial film to maintain peak performance without periodic manual cleaning. By efficiently processing the soluble waste that mechanical filters leave behind, the biological stage ensures water is not only clear, but most importantly, chemically safe for the prized koi. UV sterilization, controlling algae and water clarity. While mechanical and biological filtration are the twin pillars of a healthy koi pond, a well-designed system often integrates a supplemental component known as a UV, ultraviolet sterilizer or clarifier. This device is an indispensable tool for achieving the crystal clear water aesthetic prized by koi keepers, directly combating the frustrating problem of green water. Green water is caused by massive blooms of single-celled planktonic algae, which are too small to be trapped by even the finest mechanical filter media. The UV unit is plumbed in line with the filtration system, ensuring that all water returning to the pond passes through its sealed non-contact chamber. Inside, a high-intensity UVC lamp emits a specific wavelength of ultraviolet light. As the algae-laden water flows past the lamp, the UV radiation penetrates the cells and disrupts their DNA. This germicidal action does not instantly kill the algae, but rather renders it sterile and incapable of reproduction, effectively halting the bloom. The now inert, clumped algae cells are then much larger and easier for the mechanical stage of the filter, like a sieve or a vortex settlement chamber, to capture and remove, leading to rapid and sustained water clarity. It is crucial to understand that the UV unit's role is strictly for clarity and pathogen control. It is not a biological filter and should not be relied upon to process the soluble waste that feeds the biological media. In fact, the biological filter must be protected from the UV light, as the radiation would sterilize the beneficial bacteria, like nitrous ammonis and nitrobacter, housed in the MBBR or static beds. For this reason, the UV unit is typically placed after the main mechanical filtration to prevent fouling, and strategically positioned to ensure it does not compromise the biological stage. Furthermore, for the unit to be effective, it must be properly sized, with the correct wattage and flow rate tailored to the pond's volume. A true UV sterilizer, operating at a lower flow rate or higher wattage, can also significantly reduce the count of waterborne pathogens and parasites, contributing a layer of disease control that complements the stable chemical environment provided by a robust biological filter. Choosing the right setup, gravity-fed versus pump-fed filter systems. When designing a robust filtration system for a koi pond, one of the most fundamental decisions is the method of water delivery to the filter stages, a gravity-fed or a pump-fed configuration. This choice dictates the efficiency of the mechanical filtration and the overall system plumbing. The pump-fed system is often the simpler, more common choice for existing ponds or smaller setups. In this configuration, a submersible or external pump draws water directly from the pond, often via a skimmer or a submerged inlet, and pushes it under pressure to the filter unit, from where the clean water is returned by gravity. A primary drawback of this setup is that the pump's impeller acts as a blender for all incoming solids, mincing debris and fish waste into finer particles before they reach the mechanical filtration media. This can significantly hinder the effective removal of fines, leading to persistently cloudy or less than crystal clear water despite having well-sized biological filtration. Conversely, a gravity-fed system is the industry standard for high-end koi ponds, especially those with bottom drains. In this design, the filter unit, which must be installed level with or slightly below the pond's surface, receives water flow purely through hydrostatic pressure from the pond's bottom drain and skimmers. The key difference is that the pump is strategically placed after the mechanical and biological filtration stages, pushing only clean water back to the pond. By avoiding the pump's impeller, large organic solids remain intact, allowing for easier and more efficient removal by mechanical pre-filters like settlement chambers or drum filters. This gentle handling of debris greatly enhances mechanical filtration efficiency and also allows for the use of more energy-efficient, low-pressure pumps to circulate the clean water, which can lead to lower running costs over time. While a gravity-fed system requires more initial planning, often necessitating a bottom drain and more complex plumbing during construction, it ultimately provides superior water clarity and a more reliable mechanical barrier essential for a good koi pond filter. Advanced filtration technology, rotating drum filters, and bead filters. For koi keepers pursuing the highest level of water clarity and automated maintenance, the integration of advanced mechanical and biological filtration technologies is paramount, particularly within a gravity-fed setup. Rotating drum filters, RDFs, represent the state-of-the-art in mechanical pre-filtration, serving as an ultimate barrier to large organic solids. An RDF is a fully automatic, self-cleaning system that replaces manual cleaning with a continuous automated process. Water from the pond's drains and skimmers flows into the RDF, where a fine mesh screen traps suspended waste particles. As debris accumulates, the water level differential triggers a sensor, initiating a backwash cycle, where the drum slowly rotates and high-pressure spray jets clean the trapped solids off the screen, channeling the waste to a separate drain. This continuous operation with high filtration precision ensures large solids are removed from the water cycle almost immediately, preventing their decomposition and greatly reducing the biological load on subsequent filters. This automation and efficiency align perfectly with the gravity-fed system's goal of removing intact debris effortlessly. Once water is free of coarse particulate matter, it is processed by the biological and fine mechanical stages, often employing a bead filter. Bead filters utilize a dense bed of small plastic beads, which function dually to trap remaining fine solids and provide an immense surface area for beneficial nitrifying bacteria. Acting as a polishing mechanical filter, the bead bed captures particles that pass through the RDF's mesh, ensuring exceptional water clarity. More critically, these filters foster a robust colony of bacteria to perform the crucial biological filtration step, converting toxic ammonia and nitrite into harmless nitrate. Like the RDF, bead filters are designed for simple maintenance, typically involving a pneumatic or water-driven backwash to break up and flush the accumulated sludge and excess bacteria. The combination of an RDF for superior hands-off solids removal and a bead filter for ultra-fine mechanical and biological processing delivers a highly effective, low-maintenance filtration powerhouse essential for pristine koi pond water quality. Sizing your filter, matching capacity to pond volume and fish load. Proper filter sizing is the single most critical factor in ensuring a low-maintenance, high-clarity koi pond, a principle that dictates both the necessary flow rate and the physical size of the biological media. The foundation of the sizing calculation begins with the pond's total water volume, which determines the target turnover rate. For a lightly stocked decorative water feature, a water turnover once every 2 hours may suffice. However, a heavily stocked koi pond, due to the substantial biological load from large fish and their waste, requires a more aggressive approach, ideally turning over the entire volume at least once per hour. Therefore, a 5,000-gallon pond necessitates a filter system and pump capable of processing a minimum of 5,000 gallons per hour, GPH. Critically, a good koi pond filter must be deliberately oversized to account for the demanding fish load. Koi are large, voracious eaters and fast-growing fish that produce a significant amount of waste, a factor that exponentially increases the biological demand on the system. A common guideline for a healthy koi environment suggests maintaining a density of no more than 1 pound of fish for every 10 gallons of water. This high concentration of biomass dictates that the selected filter, whether an RDF or a bead filter, must have a greater mechanical capture capability and, most importantly, a much larger biological surface area than a filter rated for the pond's volume alone. Manufacturers often rate filters conservatively, but the intensive feeding and waste production of koi mean that you should select a filter system rated for 1.5 to 2 times the actual pond volume, particularly for the biological stage, like a bead filter. Oversizing the filter capacity, especially the biological stage, ensures that the vast colony of nitrifying bacteria has enough surface area to rapidly convert toxic ammonia and nitrite even during peak feeding times or summer heat when the fish's metabolism is high. This practice of bigger is better is non-negotiable for achieving the pristine water quality necessary for healthy koi, guaranteeing that the combined RDF and bead filter can manage both the high flow rate and the immense biological load. Maintenance and cleaning. Key features for hassle-free operation. For a high bioload system, managing a dense koi population, the efficiency of filtration must be matched by the simplicity of its maintenance to ensure the bigger is better philosophy remains practical and sustainable. The most crucial feature for hassle-free operation in a good koi pond filter is automation. The combination of a rotary drum filter, RDF, and a pressurized bead filter capitalizes on self-cleaning technology, drastically reducing the labor traditionally associated with pond upkeep. Rotary drum filters, RDFs, provide the ultimate mechanical filtration with minimal intervention. They function as a fully automatic, self-cleaning system that employs fine mesh screens, typically ranging from 20 to 75 microns, to physically separate solid waste from the water. When the screens become blocked, a sensor detects the reduced flow, automatically triggering a high-pressure spray bar to rinse the debris into a separate waste tray, which is then flushed out of the system. This prevents the accumulation of sludge, which can rapidly break down into problematic ammonia, effectively eliminating the need for manual filter sock or foam cleaning. Similarly, good bead filters, which serve as the primary biological stage, incorporate user-friendly backwash functions to purge accumulated waste. High-end systems can be fitted with fully automated cleaning kits, such as those used for Nexus filters, which control the essential cleaning cycle automatically, often running on a timer or manual prompt. This automated cleaning utilizes air blowers to aggressively scrub the biological media, followed by a rinse and backwash, effectively cleaning the media without damaging the vital nitrifying bacteria colony. Furthermore, advanced filter setups may incorporate an efficient automatic dosing system, simplifying the regular administration of beneficial bacteria or water treatments. By demanding automation and smart design, the filter system transitions from a maintenance chore to a reliable, self-regulating mechanism for achieving pristine water quality. Top features to look for in a quality koi pond filter. A high-quality koi pond filter system must be engineered with superior multi-stage capabilities that go beyond simple water movement, focusing on high-efficiency particulate removal and robust biological support. The premier feature to look for in the mechanical stage is the ability to filter down to a fine micron size. High-end systems, such as sieve or rotating drum filters, RDFs, utilize screens typically rated between 200 and 300 microns to physically remove waste before it has a chance to break down and pollute the water column. This superior pre-filtration drastically reduces the organic load on the later stages, which is critical for maintaining pristine water clarity. For the biological stage, the primary feature is the filter media's total surface area, which is where beneficial nitrifying bacteria colonize to convert toxic ammonia and nitrite into harmless nitrate. The most effective systems maximize this surface area within a compact footprint. Equally important is the system's design for optimal oxygenation and water flow, ensuring that the bacteria colonies are constantly supplied with oxygen to efficiently process fish waste. Finally, a truly quality filter system incorporates advanced features that simplify overall maintenance and enhance water quality. An integrated UV clarifier or sterilizer is an essential addition, targeting and eliminating single-celled algae, green water, that mechanical filtration cannot catch, often combining this function with the mechanical and biological stages in a single unit. Furthermore, a smart design encompasses durability with robust UV-resistant housing materials and easy-to-access components. By combining exceptional filtration performance with self-cleaning mechanisms and integrated auxiliary functions, a top-tier filter system becomes the reliable, low-effort backbone of a healthy koi pond ecosystem. A truly quality koi pond filter is defined by its superior multi-stage engineering. The mechanical stage must utilize fine screens, 200 to 300 microns for efficient pre-filtration, drastically reducing the organic load. The biological stage is characterized by media with a high total surface area and design that ensures optimal oxygenation for nitrifying bacteria. Essential advanced features include an integrated UV clarifier to combat green water and robust UV-resistant housing materials. By combining exceptional filtration performance with self-cleaning mechanisms and auxiliary functions, a top-tier system serves as the reliable, low-effort backbone necessary for maintaining a pristine and healthy koi pond ecosystem.